find the values of these amplitudes A sub L, what we need to do is to use those, uh, in fact, polynomial spherical Bessel function, and from that, and using the condition for normalization. So, what we have, one needs to do uh, the Fourier expansion, capital में, Fourier expansion of the spherical Bessel functions and using normalization Asian condition क्या हो जाएगा? So this would be an integral from -1 to +1 integral over dx iota k r k r into x. Sorry, x here. Here what we have here, function iota kr. X is basically x cos theta. So one could write this x. This x is this to uh, cos theta, because k dot r is kr cos theta. Yeah. So this x is cos theta. And so we have here also x, and then PL of x. And this is equals to, after substitution, this is equals to 2 iota superscript L j sub L of kr, and this is equals to a sub L j L of kr, which is the normalization condition, 2 upon 2L plus 1. So this would imply that a sub L जो है वो बराबर हो जाएगा 2L plus 1. 2L plus 1 is the coefficient to the power times iota to the power L. Yeah. So we could say, therefore, a plane wave can be then expressed as, सब्स्टिट्यूट कर दें ये सब चीजें. सो ई टू द पावर आयोटा के जेड, जो कि बराबर था ई टू द पावर आयोटा के आर कॉस ऑफ थीटा, एंड this is equals to summation over L is going from 0 to infinity. Then we have 2L plus 1 components, I to the power L, JL of KR, and PL spherical Bessel function cos of theta from Legendre polynomial. Yeah. Okay, so this was a plane wave. Now, अगर हम general solution consider करेंगे, so then we have to include the scattering as well. So now, instead, consider a general solution. General solution. A general situation where we have, in which scattering occurs. So if there is a scattering, so the result would be the result would be, if you remember, psi plus, yeah, psi plus sub k, which is approximately equals to summation over L is going from 0 to infinity. Then we have some coefficient जिसकी value हम निकालेंगे, CL of k, C sub L of k, and then we have the sine function जो अभी हमने निकाला है, kr minus L pi by 2 plus delta function delta sub L, and since it is asymptotic, so we divide it by kr times PL of cos theta, which is the Legendre polynomial. और अब अगर इसका solution in terms of the exponential function लिख दें, then that would be clearly representing the outgoing wave and the incoming wave. So this could also be written as in terms of uh, exponential function, that is sine को exponential function की सूरत में लिखें, CL of k. PL of cos of theta is the Legendre polynomial, which is representing the spherical harmonics. 2 iota k are the coefficient part, and then the parts which basically correspond to the outgoing and the incoming wave. So this would be e to the power iota k r minus L pi by 2 plus delta sub L minus e to the power minus iota k r minus L pi by 2 plus delta L, and this is this factor. Yeah. So ये जो wave है, again this is the outgoing wave, and this part is the incoming wave. Let's say we call this equation as equation 1. Equation 1 इसलिए कि because we would be using this equation for future simplification. So इसको आप equation 1 कर दें या equation static लगा दें, but we would be using this equation. Now दूसरे हम ये भी कर सकते हैं, हमारे पास total wave function psi k जो है, initially we wrote it in the in terms of the incoming plane wave e to the power iota kz and some asymptotic part which was e to the power iota kr upon r times some factor जिसको हमने small f सब के ऑफ थीटा कॉमा फाई लिखा था. सो हम इसको इन टर्म्स ऑफ एसिम्प्टोटिक सोल्यूशन भी लिखा जा सकता है इन टर्म्स ऑफ देयर स्कैटरिंग एम्पलीट्यूड. सो दिस इक्वेशन, ये जो साई के आपने लिखा है साई के ऑफ प्लस, सो नाउ on the on the other hand, one can write the asymptotic solution or wave function in terms of the scattering amplitudes, the scattering amplitude fk of theta, which was, if you fk of, which was initially written as, so this was so f sub k of omega, which was, if you remember, fk sub k of theta comma phi. And since we have here the azimuthal symmetry, and so this is independent of phi, so this was fk of theta, हमने finally लिख दिया था, and that could be written as psi sub k plus n e to the power iota k z, a wave traveling in the positive z direction, f sub k of theta e to the power iota k r, that is the part which is scattered, which is asymptotic. This asymptotic behavior is described by 1 over r, and so we can substitute the value, and then we have summation over L is going from 0 to infinity. This is 2L plus 1 I to the power L JL of k r PL of cos of theta plus fk of theta e to the power iota k r over r। ये हमने इनफैक्ट सब्स्टिट्यूट किए इसकी वैल्यू यहाँ पर द फर्स्ट टर्म के अंदर जो हमने निकाली, एंड देन ऑब्वियसली हम उसको इन टर्म्स ऑफ एक्सपोनेंशियल फंक्शन भी लिख सकते हैं, जैसे कि हमने पीछे लिखा है यूजिंग इन इक्वेशन 1। सो दैट कुड ऑल्सो बी रिटन एज n summation over L is going from 0 to infinity, the part as coefficient plus 1 I to the power L j L of k r, and this is PL of cos of theta। और देन वो फैक्टर जो हमारे पास किसकी सूरत में आ रहा है, एक्सपोनेंशियल फंक्शंस की सूरत में आ रहा है। सो मल्टीप्लाई बाय ई टू द पावर आयोटा के आर माइनस एल पाई बाय 2 होल डिवाइडेड बाय 2 आयोटा के आर। रिमेंबर ये इनकमिंग वेव को रिप्रेजेंट किया जा रहा है, सो डेल्टा फंक्शन आपको नजर नहीं आएगा यहाँ पे, ठीक है ना। सो देयर इज नो डेल्टा फंक्शन बिकॉज दिस डेल्टा फंक्शन जो है डेल्टा सब एल, दैट इज बेसिकली द रिप्रेजेंटेशन फॉर द आउटगोइंग वेव, या माइनस ई टू द पावर माइनस आयोटा के आर माइनस एल पाई बाय 2 होल डिवाइडेड बाय 2 iota k r, this bracket close, and then we have the scattered the outgoing part, which is again f sub k of theta and e to the power iota k r upon r, this is close here, yeah। So these are basically the uh, in fact again यहाँ पर though we are not representing, in fact we are not inserting delta sub L, but still this factor, the first factor in this square bracket term जो है वो outgoing को represent कर रहा है, और this is ingoing, incoming, yeah। In the let's say in the absence of scattering potential, this was the case, so this is outgoing and this was incoming, but in each case ये, and this is, let's say इसको equation number 2 कर दें, and the incoming wave number 1 and 2 they must be same, yeah। ये हमने अभी जैसे बात की, which and this would basically gives you an opportunity to determine the coefficient CL, yeah। So one could say the incoming waves in equations 1 and 2 are basically same, which allows for the determination of the coefficients C sub L of k, yeah। And so we have C sub L of k e to the power minus iota delta L, which is equals to n into 2L plus 1 I to the power L, yeah। और C sub L of k would be equals to किसके बराबर n times 2L plus 1, दिस फैक्टर जो लेफ्ट साइड पर है डेल्टा फंक्शन एक्सपोनेंशियल फंक्शन, ये राइट पर आ जाएगा। सो I to the power L e to the power iota delta sub L। सो देन इसका मतलब ये हो गया कि द चॉइस ऑफ दिस सी sub L of k that would determine this scattering amplitude fk of theta। And how can that be done? By matching the two equations for the outgoing part, yeah। So when we say, so then the choice of choice for C sub L of k determines एफ के ऑफ थीटा। कैसे? बाय कंपेयरिंग और मैचिंग दी टू outgoing the two equations. कौन सी इक्वेशन नंबर वन एंड इक्वेशन नंबर टू, या सो इसका मतलब ये हो गया कि दी जो आउटगोइंग वेव है वो किसके बराबर होगी? सो बल्कि टू आउटगोइंग वेव गलत स्टेटमेंट हो जाएगा, इसको हम लिखें टू इक्वेशंस। तो टू आउटगोइंग वेव्स नहीं, आउटगोइंग वेव तो एक ही है, बट वी आर कंपेयरिंग द टू इक्वेशंस, या इक्वेशन। सो आउटगोइंग वेव क्या हो जाएगी? These are outgoing waves. Summation over L is going from 0 to infinity. Yeah. And we have this C sub L of K e to the power iota delta sub L minus n into 2L plus 1 iota to the power L. And this is PL of cos theta. Yeah. And e to the power iota KR minus L pi by 2. And this is equals to nfk of cos nfk of theta e to the power iota kr over r। सो इसका मतलब है कि यहाँ से आप f निकाल सकते हैं। देयरफॉर f k of theta जो है that would be some equation summation over L is going from 0 to infinity to L plus 1 e to the power iota to delta L minus 1 whole divided by 2 iota k। ये सब चीज़ जो आ रही है ये आफ्टर सिंप्लीफिकेशन आ रही है। सो मैंने बहुत सारे स्टेप्स बीच में से छोड़ दिए जो आप सिंप्लीफिकेशन कर सकते हैं इन ऑर्डर टू डिटरमिन एफ के ऑफ थीटा बाय कंपेयरिंग द इक्वेशंस वन एंड टू एंड दोज इक्वेशंस जिसके अंदर आउटगोइंग वेव मौजूद है। देयरफॉर द एसिम्प्टोटिक वेव फंक्शन क्या हो जाएगा? ना, एक स्टेप बीच में रख लें। देयरफॉर also we need to pass the asymptotic function, and this asymptotic function is psi k of plus, which is equals to n summation over L is going from 0 to infinity to L plus 1 iota to the power L e to the power iota delta sub L. And then we have this sine function of kr minus L pi by 2 plus delta sub L divided by the asymptotic behavior kr pl of cos of theta, yeah। And then अगर आप इसको then your formula, therefore the formula for the scattering amplitude, the formula for scattering amplitude कैसा हो जाएगा? That would be f sub k of theta finally, which is equals to 1 over k summation over L is going from 0 to infinity. Then we have 2L plus 1 values times e to the power iota delta sub L sine uh, sine of delta sub L. That is the part which only contains the स्कैटरिंग अफेक्ट. सो इस टोटल साइन के अंदर हम द पार्ट वी आर कंसिडरिंग ओनली द वन वेयर वी हैव स्कैटरिंग. सो दैट इज cos theta. Yeah. And now now the differential scattering cross section किसके बराबर है? Cross section is in fact d sigma over d omega, and this is equals to mod of f sub k of theta mod square. So, and now this shows that in fact uh, this fk would tends to zero. That is fk, that is a scattering amplitude would tends to zero when all delta L tends to zero. Delta L tends to zero का मतलब ये कि delta L, delta sub L of K depends on the particle energy. So if in fact there are no incoming particle or the particle energy is small, then scattering amplitude Fk would tends to zero. And then this formula is also the basis for the partial wave analysis, and we call it as the basis because considering for each angular momentum component L, then we have the results, which is the sum of all those angular momentum. Yeah, and so this equation, this Fk of theta, this is basically giving you the basis for the partial wave analysis. So, in summary, we can say uh, ये इस इक्वेशन को अगर मैं ये इक्वेशन नंबर 3 कर दूं, so equation 3 clearly shows that f sub k tends to 0 when when all when all इसलिए कह रहे हैं because these phase factor as a function of the angular momentum. All delta L goes to 0. So also delta L is equals to delta L as a function of K. Yeah. And they depends on the on the particle energy. So there would be no scattering amplitude. Fk tends to 0 and delta L tends to 0 on the particle energy. So the above formula is the basis for partial wave analysis. Wave analysis. Why? I.e. considering the scattering for each angular momentum component and then summing all these components would give you the result, and then summing over the दूसरा कुछ और भी कुछ हम इन फार्मूलों से देख सकते हैं कि कौन से कंपोनेंट्स जो हैं दे वुड बी इफेक्टिव, कौन से कंपोनेंट्स वुड बी लेस इफेक्टिव. From the formula, it is seen that small L values contribute most and large L values would contribute less. And so this is one of the observations. So also it is expected that small L contributes most. Also, orthogonality condition की वजह से we can have a much more simpler uh, formula for the scattering amplitude or differential scattering cross section. So due to orthogonality, orthogonality का मतलब है we have different partial waves and all these waves are orthogonal to each other. That is, they have unique angular momentum values and they are normalized as well. So due to orthogonality of the PL of the PL of x, PL of x का मतलब PL of cos of theta, that is the Legendre polynomials. One can obtain a simple formula for the total scattering cross section for the total scattering cross section. Yeah. And what is that? We could write d sigma upon d omega. And this is, if you remember, ये था fk of mod square. And that is 1 upon k square. And take a mod. So summation over L is going from 0 to infinity. We have 2L plus 1 e to the power iota delta L sine of delta L PL of cos of theta, and this is whole square, and therefore sigma जो है, that is total scattering cross section, would be d omega over into d sigma over d omega, and this can be written as, in fact, 4 pi over k square sum over L is going from 0 to infinity to L plus 1 sine square delta L. Yeah. So since sine square of delta L is less than or equals to 1. Yeah. So you know less than or equals to 1 cap for small values then of delta L, obviously other than 0 and 180 degrees, delta L would be less than 1. And for L value pi by 2, for delta L pi by 2, that would be equals to 1. So that is equality. So we have this inequality or equality. So the values are either less than 1 or in fact equals to 1. And each L can can contribute at most, कितना हो सकता है ज्यादा से ज्यादा, each L would contribute a factor जो कि factors का prefactor है, 4 pi upon k square times 2L plus 1, it can contribute at the most. So this sum of the total scattering cross section is an incoherent sum, um, because different L values would interfere with each other, and so it would be an incoherent sum. Yeah. So this sum for total scattering cross section is an incoherent sum. And why is an incoherent sum? Why is that? Because this implies different different angular momentum don't interfere. Yeah. Whereas जो आपके पास d sigma upon d omega है, that is coherent because different L contributes to interference. So दूसरा दो बातें यहाँ पर, एक तो sum है, दूसरा हम कह रहे हैं the sum of d sigma over d omega is coherent. Coherent. Why? Because different different L's contribute different L contribution interface. So एक में आपके पास इनकोहेरेंट इंटरफेरेंस है और दूसरे के केस में आपके पास कोहेरेंट है. या नाउ इन द फॉरवर्ड डायरेक्शन थीटा सिफर के बराबर होगा. सो अगर थीटा सिफर के बराबर होगा तो पी एल ऑफ कॉस ऑफ जीरो जो होगा वो 1 के बराबर होगा. दूसरा कंक्लूजन है इन द फॉरवर्ड डायरेक्शन forward direction means theta is equals to 0. This would imply क्या चीज? This would imply that PL of cos of 0 is equals to 1 के बराबर होगा. And then in that case f sub k of 0, this would be equals to 1 over k summation over L is equals to 0 to infinity to L plus 1. And then we have this factor cos of delta L plus iota sine of delta sub L and sine delta sub L. Yeah. So इसका जो इमेजिनरी पार्ट है दैट इज द सेकेंड पार्ट ये कर्ली ब्रेसेस के अंदर दैट वुड बी प्रोपोर्शनल टू द क्रॉस सेक्शन जैसा कि अभी हमने देखा था. सो whose imaginary part is proportional uh, to the total cross section. So we have sigma, which is total cross section, which is 4 pi over k, imaginary part of f of 0, and this is 4 pi over k. This is sum over L is going from 0 to infinity, and that is 2L plus 1, and that is sine square of delta L. एक साइन का फैक्टर बाहर से आ रहा है, इसको कहते हैं, दिस इज नोन एज द ऑप्टिकल थ्योरम. दिस इज द रिलेशनशिप फॉर द ऑप्टिकल थ्योरम. This relation is known as optical theorem. Yeah, so this is basically अगर हम यहाँ तक भी रखेंगे तो that completes the article. But ये जो completion है ये हम बात कर रहे हैं किसके? Elastic part की. So there could be an inelastic contribution as well. जिसके अंदर यहाँ पर हमने कहा कि जो इनकमिंग पार्टिकल्स हैं, द नंबर ऑफ इनकमिंग पार्टिकल्स आर इक्वल टू द नंबर ऑफ आउटगोइंग पार्टिकल्स. Then we could also do the analysis where we would say that the in the incoming particles and the outgoing particles are different. So there could be no conservation of no conservation of the particle number, and that would lead to some inelastic collision or inelastic scattering behavior. We could also give a physical interpretation for this for this for this case, जो ये हमने optical theorem लिखा है. And obviously वो जो पार्ट है जिसमें हम बात कर रहे हैं कि स्कैटरिंग जो है वो इलास्टिक और स्कैटरिंग जो है वो इन इलास्टिक स्कैटरिंग होगी, वो उस रेफरेंस से बात हो रही है कि हमारा जो ये स्कैटरिंग थ्योरम है ये फिजिकली किस चीज़ को रिप्रेजेंट कर रहा है. सो वन कुड इनफैक्ट गिव अ फिजिकल इंटरप्रिटेशन फॉर दिस optical theorem, and this physical interpretation of the optical theorem that comes from the conservation of particles, that is either the particles are conserved or not conserved. So obviously वो हम पार्ट अभी नहीं कर रहे हैं, लेकिन फिर भी हमें इस बात को डिस्कस कर लेना चाहिए कि इससे क्या मुराद है. सो वी कुड थिंक अबाउट द physical interpretation of the optical theorem. The physical interpretation of optical theorem is the conservation. यहाँ पर पार्टिकल कंजर्व हो रहे हैं, इज द कंजर्वेशन ऑफ पार्टिकल्स. या और दूसरे प्रोबेबिलिटी. एंड सो वी कुड से दैट, लेट्स से अगर हम इसको कहें कि इसकी फिजिकल इंटरप्रिटेशन, सो देयर इज सम बीम beam of particles which are emerging after scattering along some direction. Let's say that direction is theta is equal to 0, जैसे हमने optical theorem निकाला है, contains less particles than the incident beam, and since a number of particles have scattered in various other directions, so if there are particles which are in number less than the incident number of particles, the reason behind would be that they are scattered in different directions. So this decrease in the number of particles is measured by the total scattering cross section sigma. That is the number of particles removed from the incident beam along the incident direction, that is proportional to sigma, and and obviously if it is proportional to sigma, then that is basically equivalent to the imaginary part of f of 0. So one would say that the physical interpretation, the beam emerging after scattering along the incident direction, because theta हमने सिफर लिया है, along the incident direction, theta is equals to 0, contains less number of particles than the incident beam. Then the incident beam. And this can be attributed since a number of particles have scattered in different directions, have scattered